Good morning, good afternoon, and good evening, everyone. This is David I, and I'll be your host for this webinar, Learn How to Quickly Build and Deploy a Complete REST and JSON-based Enterprise Business Application. Also helping me today are Mannarino and Kelver Merlotti. They'll be doing the demoing of Enterprise Mobility Services and the DataSnap technology. Here's what we're going to cover today. I'll give you an Enterprise Mobility Services overview. Then Al will demo how to build an EMS solution. Then I'll come back and give you an overview of the DataSnap multi-tier technology SDK. And Kelver Merlotti, one of our MVPs, will do a demo of building DataSnap solutions. We'll end the webinar by comparing EMS and DataSnap, and then we'll take your questions. Let's get started. What is EMS? It's Embarcadero's Enterprise Mobility Service solution. It gives you a turnkey middleware server solution enabling user management and authentication, loadable modules for custom APIs over REST, enterprise SQL database access, mobile embedded and server-side SQL data storage, support for push notifications, both for Apple push notification service and Google Cloud messaging. And it gives you a web console for user, groups, device, and API analytics support. Why use EMS? If you want to build a mobile solution that requires a strong backend for enterprise focus, EMS is for you. If you want a turnkey cloud-ready solution that's fast and easy to deploy, EMS is for you. The capabilities at EMS are critical for enterprise acceptance. It also allows you to build shared customer backends if you're a VAR, an ISV, or a service provider. As I mentioned, EMS is a multi-tier REST and JSON-based solutions. The EMS clients use REST API calls. You can leverage embedded secure databases that are included in EMS. EMS servers host plugin packages, and it uses the EMS database under the covers to support storage of your user information, group information, and analytics. EMS packages can also connect to enterprise databases via FireDAC, as well as cloud-based services to extend the capabilities of your EMS solution. EMS packages can be run standalone, or they can also be hosted inside of IIS by Microsoft. And Linux Server is on our roadmap for the future. Your EMS server is easy to set up. There's a setup wizard for configuring the EMS server, for generating sample data, generating the database under the covers that EMS uses, generating some sample users, the console, the username and password, and then finally creating all of the INI file, database, and configuration file infrastructure. After that, you can then go in and start defining your endpoints. You can also modify the configuration to set up your push notification information for the backend push services that you want to support. The EMS server comes with a management console, both for development and for production. It allows you to start the EMS server, add users, create groups, look at your users, and so on. And as I mentioned, EMS supports push notifications for both Apple push notifications and Google Cloud messaging. So if you have mobile clients and you want your application packages and your business logic to push notifications and information to the mobile clients, you can do that yourself through EMS or through the console or through code that you write inside of your business logic. All of the APIs that are called, all of the endpoints that are used, analytics are being tracked and stored, and you can use the console to go and look at what's going on and who's using your EMS server. So let's take a look at a demonstration by Mannarino. He's going to build a complete EMS solution for you.
EMS server is either a Windows 32-bit or Windows 64-bit executable, so it starts up. We can see here by default, it includes a few administrative APIs, like what version is it running, what users are logged into it or connected to it, what groups do I have, what types of apps have already connected to it. Those are the installations, what iOS devices, what Android devices have connected to it, and we also include push notification. So just to make sure this is working, that my outside devices can connect to it, here is my Android device. And a quick way to check, I'm just going to bring up a browser. I want to call one of its endpoints like versions. And if it comes back with the version, yes, so EMS server is running with version 2.0, so that's all working well. And the other thing I want to just check, just to make sure that my Google Cloud ID is correct, I have a sample app I use here called EMS Push Client. So this EMS Push Client wants to talk to my EMS server, and I just want to quickly send it a push notification just to make sure the communication's working okay. On the EMS side, we give you this great EMS management console. So I just want to authenticate. I want to log into it. So I'm logged in successfully. And from this console, you know, what users are registered to my EMS server, what groups have I created. Installations is what devices have connected to it. So here's my Android device that I connected to previously. And I can send push notifications from it. So like under installations, if I go back to the sample app and I click this button, you know, test connection, it brings back the version just to make sure I can connect to the EMS server. We have a button here to do register installations. So this registers myself to EMS, and by doing that, it knows the type of the device, the operating systems, all that great stuff is part of that registration process. And I just want to quickly check if I could send a push notification. So on the data, I just want to say hello from EMS, and where do I want to send this to? So these are the devices that are available to me. So I'm going to click this one, which is the EMS device that just got registered. So when I send this push notification, and EMS pushes the notifications out. So now if I go back to my Android device, then sure enough, there it is. So push notification got sent. All right. So when the EMS server comes up, we can open up its browser, and all those endpoints we have here, like version and users, is here. But part of this is also a console. And from the console, here we can get all this great analytics about EMS. So log in as the console. I can see the users that have come into the EMS server, any groups I've created, any installations I have. So here's my Android device that we just connected to it. And then these great analytics as what's going on inside of it. So I can see statistics like total clients, API calls, user API calls. So all of the API calls that people have that are using inside of this EMS server, I can get some nice statistics on this. So I could find out what endpoints, what resources people are going after, and where should I spend my most time on what resources and what endpoints. And here we can export this information out to a comma-separated file for offline analysis. So that's a quick peek at the EMS console. EMS comes in two versions, either a 32-bit Windows version and a 64-bit Windows version, and they get installed in the RAD Studio bin or the bin 64 folder. So to start the EMS server, it's just this executable EMS dev server. So when you start it for the first time, it's going to invoke this EMS setup wizard. And if you just click all the defaults of the EMS wizard, it's going to end up creating this EMS development server that we see here. So if we look at it, it says it created our EMS server configuration file. It creates our EMS server interbase database. In my case, I'm using the EMS development server, so it's a not licensed version. So it's the development version that you get inside of a RAD Studio, and it allows me to test with 5 default users. And then we give you these default administrative APIs. What version of the server am I running? What users are inside of my server? What groups have I created? What installations? What devices I've connected to my EMS server? And it also gives me the ability to send push notifications. So all of this comes by default. If we take a quick look at where these files get created, I have it here. So when you do this by default, it puts it in your users public documents Embarcadero EMS. So EMS server.ib is the interbase file it creates. The EMS server.ini file is the configuration file it creates. So if you move the EMS database, here's where you give it, where you put the EMS database. You can set extended passwords on the encrypted interbase database. You have your connections. If I go down to SSL, so if you want this to support SSL, there's an option to select SSL. For the push notification, I'll tell you where those two pieces are. So to do Google push notification, so you go to a developer's Google account and you get a free Google Cloud Messaging ID, and you put that API key here. That's for Google. For Apple, if you have privileges to create your own Apple push notification certificate, you can do that yourself or get your admin to create it. You'll end up with this push notifications certificate, and that's needed to be able to push notifications to Apple devices. So that's kind of what really needs to be done here for what we're going to cover today. So as we see here, it's this EMS server. It's running on my Windows IP address in the default port of 8080. So now you're able to call these EMS administrative APIs. So EMS being this turnkey middleware server. So out of the box, you get these administrative REST APIs for built-in resources to do version, users, groups, and installations. And as you can see here, these resources expose endpoints like get users. You know, for users, I can either get all users or get an individual user. So EMS is using standard HTTP, REST, and JSON, JavaScript object notation. So we can call these endpoints from a browser. So if I open up a browser, you know, by default it says do the version endpoint. Instead of version, I could ask for users. And here's all the users that I got registered. So you see for users, it did the get, so it returned a JSON array of all of my users. But if you looked at users, it also had a get item. So I can pick an individual user, and I can ask just for its JSON object to be returned. So if I take this user here and say I don't want all users to come back, I just want this individual user with this individual ID, then instead of getting back that JSON array, we just get back the JSON object just for this one user. So one way of accessing the EMS server is through this browser for testing purposes. So by default, we have these administrative APIs in here, but we want to now be able to extend the endpoints and the resources with our own custom resources and endpoints. So when you extend this EMS server using runtime packages that we're going to define and register resources, and we do that by this nice wizard inside of RAD Studio. So if you go to File, New, Other, you'll see for both CBuilder and for Delphi, you have a new EMS node, and from this node is where we can create new EMS packages. And inside these EMS packages is where we create our modules, and those modules become our new endpoints and our resources that we can use to extend it. So, for example, if we want to create a new custom resource, a new custom endpoints, we'll say package. So you can create an empty package that doesn't register the resource. You can do that later, but in our case, we want to create a package with the resource that we want to get registered to the EMS server. Resource name, I'll just call it demo for now. You can put it inside of a data module. Now, data module is usually reserved for if you're going to connect to backend databases. It gives you a nice surface to add, data access components, or it could be in a standalone unit. But I'm going to pick it as a data module because I like working with data modules. And then these are the endpoints that you can ask for or include. Get item, post, put item, and delete item. So you can select them all if you want. So this module gets created. And as you see here, it's a BIPL, so it's a package. So this package cannot run on its own. So to help us, either on the run parameters, we see here when we run this project, it's going to first start the EMS developer server, and then it's going to load this package into the server with our newly created custom resources and endpoints. So if we look at what it creates by default, you'll see here it created a resource name of demo that's inside of a T data module, and we have our get and our get item post. If you take a look at some of these have this resource suffix item, and those are the ones that allow me to to pass parameters to it. So, for example, if I just did a get, I get everything returned. But if I did a get item, I can also pass an individual item like we did for get users to return one individual user. We have the same for put item and the same for delete. So inside of here is where you would add your additional custom resources and endpoints. So these are the same files we created. This time I called my resource name my resource inside of a T data module. What I did for this one is I created a new custom endpoint called reverse string. So its signature is very similar to all of these others. So, and because it's a reverse string where I want to pass it in a value, a parameter, and then run the reverse string on it, it has this resource suffix on here. And then to implement it, similar to how we used to do with the if you ever ran a DataSnap server and you asked for the sample methods, this is kind of one of those sample reverse string methods we did there. So here's the implementation of reverse string. Get the reverse string, pass in an item, and then do the reverse string function on it. And that reverse string function is part of system string utils. So the great way or the great reason to use RAD Studio to create these custom resources and endpoints is you can use all the power of Delphi and or C++ Builder to create these custom endpoints for you. So we're going to show another EMS server where we included a FireDAC and a data module to get to backend databases. So kind of just how we did before, we ran the EMS Wizard. We created this EMS FireDAC resource package. Inside of the package, we have a module, and on the data module, we added our FireDAC connection. So this FireDAC connection will connect to whatever backend database you want it to connect to. It's got query components that queries backend database. You can check it here just to make sure it works. Query customers, query the orders. That's all working fine. That's the backend EMS server where we have extended inside of this module. We created this resource name called test inside a data module, and it's got endpoints like get going through FireDAC and post going through FireDAC. And we do their implementation here. And we see here we're using the FireDAC schema adapter. It knows how to save to stream and load from stream. So it's a very powerful capability of this FireDAC schema adapter. Once we return the JSON object out from EMS through FireDAC, we can now take that data and convert it to a nice tabular form to display inside of tables. Let me show you this running and we'll see what it looks like. So again, we see here we created a new resource called test that has endpoints of get records and post updates. So to test it, so if we just ran test, it should return everything back from the database. So if I open up a browser and I pass it test, it goes through EMS, uses the FireDAC connector to get to the backend database and returns a nice JSON array of all the data. So that's cool. So now we can use this endpoint inside of client applications. So for EMS, we include an EMS provider. So the important properties here is where is the EMS server running, what's its URL host, and what port is it running on. There's an EMS FireDAC client, and this tells us the resource that we want to hit. So in our case, we want to hit the test resource. And if we looked at the two functions here, get tables and post tables, so when I call get tables, inside of that test resource, there was the get data endpoint that's going to return data from the EMS server through FireDAC, and the other one was post updates. Any changes we make will get posted back to the database using this FireDAC data access client component. So EMS server is running. So when I run the client and I do get tables, it does the get data and returns back the data. So you get that nice JSON array that comes back, and we can format it nicely into this master detail type of format through that FireDAC schema component. So that does that very well. Then any changes I make here, if I make a change and I post it, it will do its post. So that works out all fine. So that's a quick look on how you can use EMS custom packages and include the FireDAC data access components to get to backend database resources and return the results back to these call-in clients. Right now we want to get into push notifications. So for push notifications, like you see here, we can even use VCL client apps to send push notifications to mobile connected apps to EMS servers, or they can be FireMonkey multi-device apps like we saw running before. So before I had this running on my Android tablet, it looks like this. So in XE8, we added push notification support inside of EMS for both Google Cloud Messaging and Apple push notifications. So you can have a mix of devices registered into EMS, and it's very simple to do the registration. I'm going to say the most coolest new feature we put inside of EMS is be able to do push notifications, but it's very critically important for these mobile architectures because it's the only way, it's the conduit to notify mobile applications even when they're not running on the device. So what's cool about that, there's no background thread that's needed. Part of the Google Cloud Messaging and Apple push notifications does all of this push notifications for us. We give you this ready-to-use component called push events, and this is what it needs to do the push notification. So the only two components I have on here to enable me to do push notifications, one is the EMS provider, like we saw before. Give me the IP address and the port of where the EMS server is running, and then we drop a push events on here, and we just connect the provider name of push events to the EMS provider, and then push events has a event called push events received. So the EMS sends out the push notifications, and then when the client receives the push notification, it triggers this push events push received. And here at the very low level, we package up that push notification either coming from Apple push notification or from the Google Cloud Messaging. So it's as simple as that. Even the basic default EMS server includes push notifications right out of the box. We pre-configure this for you. So then you can create applications to send push notifications. So if I now go to the application we created and I click its test connection, just to make sure I can connect to the backend server, EMS server. If I click on register the installation, it registers this device to the EMS application. So now at this point, the fact that EMS knows about this device makes it easy for me to send out push notifications. So just like how we did before, one nice way to do it, in addition to the EMS console, we give you an EMS management console that we can check authentication, log into it, and we saw we could send push notifications. So I'll just do this very quickly again. Hello, where do I want to send it? So these are all my Android devices that have been configured, that have been installed on here. And when I say go send it, it sends it out there. And we see how easy it is to send a push notification to Android, and the same thing works with Apple on iOS devices. And you saw in the EMS configuration file, I needed to go up to Google and create a Google Cloud Messaging ID, and I also need an Apple push notification certificate to allow me to do this to iOS devices. Same thing we can do from a VCL application also. So here's a VCL application. The only two things I need to drop onto a VCL application to send push notifications to clients is, once again, drop the EMS provider on here, tell it where my EMS server is running, IP address and port. And now here we have the back-end push component. This is a component for requesting a push notification, not receiving it. And it can be any type of application, including the VCL application like we see here. So to trigger the notification to do a broadcast, all you really need is a one line of code. So once we have an EMS provider on here and a back-end push component, all I have to do is tell it the message I want to send and then call its push method, and it knows how to broadcast, push that message to all of the connected devices to the EMS server. So that's also pretty cool. All right, one of the few last things I want to show you here is how we extended EMS to do external credential checking. This was a request from customers saying not only did they want to allow our included interbase database to do authentication and authorization, but some folks had external login authentication like LDAP or Active Directory. Inside here, we added a new resource called Custom Login that knows how to go outside of the EMS server, take the user ID and the password that you provided to us, and use external credentials like LDAP or Active Directory to do this. If we go into the code, here we have a resource name called Custom Login. And here we do it a little bit differently. So when we do the EMS custom login resource, it's a different resource type and the registration is a little bit different, because by doing it this way, we're telling the system not to expose an API, but for doing a registration. So instead of letting EMS check for the username and password in our included EMS interbase database, you can prompt for the username and the password, and then you can check it from an external credentials database. If I run a client, I have the option of either using our own included interbase database to check for login. So I have my test one and my test one. So this is going to our own internal interbase database, and it's happy it logs in correct. But if I switch this to custom resource and I do the same thing, so this is going against the Embarcadero credentials, and test one does not exist there. So if I try to log in there, it says, sorry, that username or password is incorrect. So it's nice to know you can take EMS and now you can add this external credentials checking support for the backend databases.
Thanks, Al, for that great EMS demonstration. What is DataSnap? It's a middleware SDK for building multi-tier applications. It works with standard-based infrastructures, TCP/IP, HTTP, HTTPS. You can use REST and JSON. It's Windows-based. We have Linux on our roadmap, as I mentioned before. You can create a console for your DataSnap server that is a forms application. It can be a simple command line application. It can also be a service application and an ISAP DLL. Why use DataSnap? Well, if you're a do-it-yourself and you want to build everything up from some base level components, then use DataSnap. You can build your own custom Windows GUI console. You can control the server lifecycles. You can leverage callback mechanism that's supported in DataSnap. And you can run it as a Windows service application. So you have your choice, some assembly required, quote unquote. DataSnap has many features. You can communicate between the client and server via local host, the local network, through the internet. You can even implement the client and server in the same application in process. As I mentioned, the connectivity are the standard internet protocols. Server lifecycle control is invocation, session, and server. A session means as the client is connected to the DataSnap server, it stays alive until the client goes away. If you want to just control an invocation or a call from a client to a server, use invocation. If you want the server side to do stateless and you do all the work, you can set server lifecycle. And connection pooling is supported. You can also do HTML using the web broker DataSnap server. That's one of the options. You can route data transfer through a tunnel. DataSnap, as I mentioned, supports callbacks where you can broadcast through a channel and notify callback. Communication filter APIs are provided, and we have sample filters for encryption and data compression. And there are other DataSnap filters on the internet. You can use JSON data content as well as passing your own data back and forth. We enhanced DataSnap in 10 Seattle. DataSnap HTTP and HTTPS now use the native HTTP libraries on each of the platforms in system.net. So there's no need to deploy OpenSSL client libraries anymore. We've also improved the DataSnap FireDAC integration using a new component, FireDAC JSON Reflect, with data compression to provide better throughput. We also support the FD schema adapter in DataSnap servers that can be used in your DataSnap applications that makes it much easier to work with master detailed database architectures in your applications by connecting the schema adapter on both sides. and then the JSON is sent between them with the metadata and data for the master detail relationship. Makes it much simpler to do your database operations, do your apply updates without having to go and do the detail operations and the master operations. There's a DataSnap Wizard to get you started. It's an easy way to get started, but you can also create your DataSnap server application from scratch. The components used as a base of DataSnap is the T DataSnap server component, the server class component, and the transport class of your choice. And the wizard has multiple steps that take you through making your choices, forms application, either VCL or FireMonkey, a console application, and so on. There's a separate wizard for REST-based DataSnap server as well. And now we'll have a demonstration by Kelver Merlotti, one of our Embarcadero MVPs, on building DataSnap solutions.
So here I have a server, a DataSnap server and DataSnap client. On this server, we have a server container that was generated by the DataSnap server wizard. And here is the main component responsible for the security of the DataSnap server, the GS authentication manager. On his own user authenticate event handler is where we can check, we can test if the user credentials are valid or not, and assign to this user a role. In this sample, I am calling a method, a class method called validUser that is implemented on this data module with just a FireDAC connection and a query that selects from the employee table the number of the employee and his job code, considering his last name as username and his phone extension as the password. So we have a class method here that receives the user and password, pass to those parameters its values. Then we open the query, and if this query isn't empty, the user was found and it's a valid user, then we will return valid through as the function result, and also the employee number and their job code. Back to the server container, we will receive these three information, that if it's valid or not, his ID and his role, and if it's valid, if it's a valid user, we will register his ID on the session and test if the role this user has is one of these selected roles to be an admin. If this employee doesn't apply in any of these job roles, we will assign to him the user profile. And now that we told the server that he's a valid user and told him in each profile or in each role he's assigned to, we can authorize this user when he tries to do something special, let's say. And to demonstrate this usage, I define it here on the authentication manager on its roles collection, that all the times that a user calls an applyUpdate method, only the admin's user or only the users that was that were assigned to the admin role will be authorized to do this apply updates. So users profile will never apply updates, only the admin ones. And beyond that, on our server methods that has just 3 methods, the 2 generated with the wizard, the equal string and reverse string, and a new method called getSalary. This method will only be able to be executed by admin users. So if any employee that were assigned to the user profile won't get to execute this method. Let's run the server and take a look on the client. Here we just make a connection to our database DataSnap server using the user credentials that was inputted here, and we have the possibility to execute the get salary method through the SQL Server method. Here is the method we're gonna call. Also, we can get the customers, opening the client's data set and try to apply those updates that will be able only to admin users. Let's run the client now and check if it's working. First, we will log in with a user that are not on those selected jobs. His password is 6. Now we connected. If we try a different password, it won't connect. It will reject the user credentials. So only the specified users that on the database active will be able to log in on the DataSnap server, and just those authorized users will get the salary. You can see that he can't perform the requested action, and also this kind of users won't be able to change the data. He can change locally, but when he tries to apply the updates, it will fail again as he is not authorized. If we connect with some user that is on the admin role, we can get the salary from any employee. We can execute the get salary function. We can change the values of the data and apply the updates without any problems. That's it with authentication and authorization. Here we're using the same server and client from the other sample, from the authentication sample, and what we need to do to enable the filters are really simple. On the server side, we need to go to your TCP server transport component, and on the filters collection you need to add the filters you want. Here I added the compression filter on our server, and on the client side did the same on the SQL connection component. If we expand here the driver properties, we also have a filters collection where we need to specify the filters we are using. So here I use the same filters, and another important thing to remember is to add to the use clauses of your unit just in one of your unit the dbx compression filter if you're using the compression filter as in this example. Now if you run the server and the client, we can do that everything works on the same way. Here we go, connect to the user, get the salary, and get the customers, and go on. But I used an application called raw cap that monitors the traffic over TCP/IP, the local traffic of TCP/IP, and got these two files. And I would like to show you first the file with where when the server wasn't with filters. There was no filters in the server and client, and on the method that was called to get the customers, it had to execute two fetches from the server, one with this length 1460 plus 761 bytes. It costs two fetches to get the data, and when we enabled the filter on the client application, the same request could be done with one single fetch of 1400 bytes, so almost 800 bytes smaller. So it's really a nice feature that's built in and ready to use with DataSnap. To the caching demo, we created a DataSnap REST server application, and on the server methods unit we added two methods that returns one image as a stream or two images as a stream, one in the result and the other on an out parameter. And to test the parameter caching, we'll put a breakpoint here and run the application and test it on the browser. Let's take a look here in Chrome. We have a debugging tool that is activated with the function 12 key, and I also have a tool that's called Change HTTP Request Reader that enables us to make some changes on the headers that are sent in a request. So first, what I'll do here is to call the getImage method, and we can see here that a session was opened in our DataSnap server, and this is his ID. The response was the image, the single image that we got. If you need it as a JSON, you can put this parameters on the end of the URL, and it will give you an array of bytes in the JSON format. Now, if we get the get images method, but before it I'll make some changes. First, saying the dash session ID and the pragma header as the DataSnap engine requires to tell the server that this request is on the same session that the request made earlier. And on the accept header, I'll tell the server that I want application / REST content. When I do these changes on this change on the reader on the request header, I'm telling the server that he is able to cache complex types. Now, if I do execute this request, it will execute the method. Now you can see that the breakpoint was activated, and back into the browser we had we had a download file because it was in a stream, but we don't want this content. We want the cache content. Now, if we change the URL to this one, we'll have an image, and take a look that the breakpoint wasn't enabled, so it was not processing our request. It was getting the value from the cache. Okay, so here it is, the REST parameter cache of DataSnap working. Now, the other part of the cache we talked about was data, cache of data, and what I did here was to create another server method descended from the data module, and this server method I just dropped a FireDAC connection and a FireDAC query listing all the countries from the employee database, and the method countries returns a data set. What I do is if the memory table is not active, I open the query and copy the query data set to the memory table and send as result this memory table. So the next request to this method will not open the query again, because the memory table will be active and will only send its content again. So if we open one client to this application and get the countries, the breakpoint is stopped, the query is open, and the data is copied to the memory table and returned to the client application. Now I'll open another client and get the countries again, and look that the breakpoint wasn't enabled because the memory table is already active and his content was sent. This is a kind of cache from the server side. We had an instance, a single instance of the server method, that this was done using the server class lifecycle here on our server container. In this case, in our web module, I have another server class which lifecycle is server. It means that only one instance of this server method, of this data module, will be available until all the life of the server. No matter which client requests, it will get the data from the same source, from this instance of server method. Then we have a cache in the server side. But what I also did is that when the client gets his data, it saves locally its data. Here it is. And this means that even when the server is not running, but we get an instance of the client, we can get the data. It's there, it's locally. We don't need to go to the server. And come on, how many times this kind of data will change in years, isn't it? So it's totally possible to store this kind of data locally, and sometimes to check if it's necessary to update your local cache. The clear cache just drops this local data and will force a new fetch from the server. In this case it failed because the server is not running. If we start it and try again, we probably will get the results. There it is. And let's just, before I finish, take a look in the client side how it was done. It's really simple. On the get countries button, we test if the file exists and load the data from the file. If not, we calls the countries method from the new server method we created and copy the result, the data set that it results, to the memory table. And on the clear cache button, it's just to delete the file that was specified in this constant. So it's just an idea to make you think more about cache or data. To this demo, I created a DataSnap REST server that has mainly two methods. They are the echo string and the customers method that opens a query and return it to the client. Let's run the server, and on the client side we have at the top a way to test the substring filter, remembering that the substring is also applied to streams. So here we can test over characters, but you can also do the same with the bytes of the string. For example, the count function will return the first 5 letters. First we need to start our server, and then echo string the first 5 letters. If we use the offset function, it will skip the 5, and if we use the range function, for example, skipping 5, getting 10, it will get the 10 letters after 10 characters after the first 5 characters. And with the customers, with the data or the table filter, what we did was to specify the number of records per page, and when we get the customers, it is filtered skipping at the first page, no records, and getting 10, count 10. The next page it will skip 5 and get more 5, and the third page skip 10 and get more 5, and so on. This was done using this property current page and the get data method. This get data will get the filter accordingly to the page. So we get the count from the spin edit, and the skip is based on the current page. Then we will create this filter, and the get data method will call the customer's method, passing this filter to the server. Remember that when using filter, you are still loading all the content in the server, and after load it, you will filter what goes to the client. So pay attention on where and how you use the filters. To the callback sample, first we'll take a look at the callback method. Here I have a button that calls a method on the server called generate report, and this method has an interesting parameter that is a dbx callback, and that's the key point to the callback method. Here we can tell the server how it can call us back. We will send a structure that the dbx framework implements to give the server the ability to send us some JSON value, and when we receive this JSON value, we will call the update progress method, passing to it the value. And the update progress method will only use the synchronize thread method to update the label and the progress bar here on the screen. And while the main thread will be busy waiting to this response, the server will be sending us the feedback about what is he doing, and we need to do this in a thread method using the synchronize. So on the server side, what happens is that on the generate report, we simulate a process doing a for from the start to the end and waiting to it, and on each step we create a status that is a JSON object and add one value to this object. In this case, only the step we are, only the number of the step we are. We could do many values as we want here on this callback method and just handle this data on the client side to update your screen. But now only we need is this feature, this implementation. The client will send the server an object away, a callback object, to tell the server how it can call back the client. So when we get the report, at this time the main thread is busy waiting for the report, but the server is sending us back the feedback about what is it doing, and then we can update the progress. This is how the callback methods works. Now let's take a look about the channel, the callback channel. On the server we don't need anything else, anything different to implement a callback channel, because everything we need already is already on the DDS server. For example, if we get its name, we can see that we have the broadcast message, for example, and here you can pass the callback name. But on the client side, it's where the key point appears, because although the server could talk to the client, first the client needs to tell the server how to talk to him. Here we saw how to do this using a callback method, and to create a channel to a server with a server, we use this component, the client callback channel manager. It has two main properties that are the channel name and the manager ID. Then we can on create event we can generate a name to this callback and a name to its manager. Now the channel manager component can register a callback using these IDs, using the callback name and mainly the process, the object that will be used to this used by the server to send the content. That's the same object we used on the callback method. Just in this case, it's just a simple example. Now, with that said, when we register a callback, it's like we have a way, an open door between the server and the client. And if we have more opened clients, they could talk with the server and broadcast message. For example, let me connect this and this client, and I wanna send this number to everybody that's listening to the channel. And there you go, they're listening. If I send a number less than 10, that the max of the progress bar at this time, it will work. And another thing we're able to do is to send to a specific client. So if I get these credentials and send a different value to this specific ID, only this client will receive. Otherwise, if I send some value to the entire channel, everybody that was registered in this channel ID will receive that message.
Thank you, Kelver, for that great DataSnap demonstration. I just want to spend a few minutes talking about deploying your EMS and DataSnap server applications. There's lots of documentation included with the product, as well as on our doc wiki. The first file is the RAD Studio deploy file. It's an HTML file that includes information about how to distribute or deploy runtime packages, enterprise mobility services, and the things that go with it. So you'll see this document along with file lists inside of this HTML file. For deploying applications in general, we have runtime packages that are in a redistributable folder and or in the bin folder of your installation. And so this lists a bunch of the runtime packages and assemblies that you have a license to redistribute with your applications, including if we go down to a set of DataSnap package files that you can distribute, including FireDAC to access your remote database servers. For deploying the enterprise mobility services, there's a special section which gives you a list of the 32-bit and 64-bit DLLs and executables that are part of development and deployment of an EMS application. There are doc wiki notes about how to install the EMS server and EMS console server on a production environment, including lists of files and so on, for both 32-bit and 64-bit EMS servers. Inside of the installing EMS server and EMS console server in a production environment, there's information about the IIS support for EMS server and console. And so here it shows you how to make sure your IIS is installed, checking that it's running, and creating the site, which is going to be where your EMS server-based applications and console are going to live. There's additional information about configuring IIS for the EMS ISAPI DLL and how you set up the configurations for those two files, the EMS server.dll and the EMS console.dll. We have a separate document to remind you about the EMS runtime license for development on an enterprise and above edition. we give you 5 EMS users valid license for testing inside of a development environment. When it's time to deploy your EMS application, then you'll need to contact our Embarcadero sales offices and or our reselling partners around the world. And these licenses are used to set up the EMS-based interbase instance for your production environment for user management. And then finally, there's a document that gives you information about the database requirements for the production environment for EMS to run. EMS uses interbase exe7 encrypted database inside of a production environment. So part of getting the EMS license is to get the interbase licenses for the users that are going to use your EMS server in the production environment. So that's a quick overview of the resources and information about how you can deploy your EMS applications to a production environment. For DataSnap deployment, all you need is your Enterprise and Higher edition that comes with the DataSnap deployment license built in. You can deploy your DataSnap servers on whatever Windows-based servers that you want. To finish the webinar, I just want to talk about the comparisons between EMS and DataSnap. These technologies are both included in the Enterprise edition of RAD Studio, Delphi, and C++ Builder. EMS is a turnkey solution. DataSnap, it's do-it-yourself. In EMS, you create server extensions exposing REST APIs, and the database is via FireDAC. In DataSnap, you can build your own servers up from TCP, HTTP, and REST, and can also use FireDAC. EMS is fully stateless and scalable. On DataSnap, you have support for the 3 types of lifecycles that you can mix and match. Also, DataSnap includes heavy and lightweight callbacks. EMS includes user management, group management, push notification support, device support, API call analytics, and the console for managing your EMS servers. In DataSnap, you can build your own console, you build your own servers, you can even integrate your own analytics. You do the work. An EMS solution can be self-hosted inside your firewall on a server. It can also be hosted in a cloud instance. And you pay a license fee for groups of users. DataSnap solutions can be self-hosted inside your firewall or in a cloud, and they're free to deploy with your enterprise license. The EMS solution also includes our Interbase server and Interbase to go to provide secure database operations at the database level and at the column level, both in the EMS server as well as on the client. We have a special offer that's good until March 31st, which allows you to upgrade from a previous professional edition of RAD Studio, C++ Builder, or Delphi, to move up to the Enterprise edition that includes EMS and DataSnap, and save 35%. The discount is applied when you purchase the upgrade. It also includes the free bonus pack with the new Object Pascal Handbook by Marco Cantu, VCL and FireMonkey Premium styles, and the Media Converter Basic Edition to convert VCL applications to FireMonkey. All the details and terms and conditions are on the RAD offer page with the URL at the bottom of the screen. And again, that's good until the end of this month. Here are some learning resources for EMS and DataSnap. You'll find links to the DocWiki top-level indexes for enterprise mobility services and developing DataSnap applications. There's a set of tutorials for building EMS applications and DataSnap applications. And Pavel Glavatsky has his DataSnap labs. I think it's 11 or 12 tutorials to get you started with DataSnap. This is the blog post for this webinar, and all of the URLs and links are on that blog post right now. So you don't have to worry about typing all of these URLs down while we're doing the Q&A. And now it's time to take your questions. And if you have other questions after the live Q&A, just send me an email to david.i@embarcadero.com. Okay, Jim, let's see. Can the data exchange between EMS server and EMS client be encrypted? And I think there's 2 answers that I'll give, and then maybe Paul can get in as well. One is you can configure EMS so that it uses HTTPS between the clients and the servers. And that's a configuration setting. Under the covers, we use the native HTTP libraries for each platform now. So, and HTTPS. In the past, couple versions ago, it required OpenSSL deployment on the client and server side, but now we use the native platform HTTP interfaces for Windows, OS X, iOS, and Android. The second thing is that you can decide to encrypt, decrypt, for that matter, compress and decompress the JSON stream that's being sent between client and server, and you do that in your own code. There's no encryption specific component. We shy away from putting encryptions into our products other than, for example, interface at the database and column level, going up to AES, I think 256 or whatever, because there's some export controls, but again, the hooks are there for you to let you use whatever, whether it's crypto APIs from Windows or other platforms to do encryption. So you've got the two options: let HTTPS cover it, and then encrypt and or compress if you want the JSON.
I'm here, checking if you can hear me.
Yeah, we hear you, Al. Anything else about the encryption of data between EMS server and EMS client?
So in addition to what you said, so what we showed here was the EMS developer server. For production, we'll give you an EMS Zappy DLL that you'll drop into a Microsoft IIS container, and then with that you can use Microsoft's IIS encryption. So you would create an HTTPS binding to enable any SSL, and then in the EMS server INI file, you can enable HTTPS support by setting HTTPS equal to 1 to add additional security.
Excellent.
So the question here about if you can use LDAP for your authentication.
Well, I think it was two parts. One was Al showed how to use an authentication interface that's now added in EMS. I think the question went beyond that to say, once you've authenticated a user, what do you have to do, for example, to give that user access if your EMS server, one of the endpoints, is going out to Oracle? And there, Al, you can see that the user is authenticated because they can get in and call an endpoint. You can then get the information about that user, right, and then decide whether that user in your own business logic in the endpoints can connect to something that's beyond the EMS server, right, whether it's an Oracle database or some other service that your endpoints in the EMS are wanting to connect to or leverage.
Yeah, so that's all you said there is correct.
You do, so you do it in your code. We don't have something that sets flags per user for access of things that your endpoints are accessing. You would do that in the endpoint logic in the code itself. But as Al showed, there is authorization authentication that you could do. And Pavel also covers that. I think it's in tutorial 11 in his DataSnap labs. He talks about authentication if you're thinking about DataSnap. And I mentioned that it also mentioned in there about DataSnap if something else is going on. You can mix and match EMS and DataSnap servers. You can have multiple EMS servers. You can have multiple DataSnap servers. You can have multiple REST servers, SOAP servers. You can integrate all of that into your application. Your endpoints, as the diagram showed, can call, in the endpoint logic, you can have REST components in your endpoint logic that would go out to REST servers. You can have DataSnap components that would go out to DataSnap servers. So you can integrate all of these things together in your EMS server and let the endpoint logic access all of that stuff. And the diagram shows that sort of fast providers, cloud stuff, your remote databases, all of that is integratable just by using the data access components and REST components and putting that into your EMS server endpoint architecture. There was a question here, Al, and I sort of answered it, but I had a typo. It was about EMS push notifications, can you send to a group? I know we can send to, you can create a channel, and you can then send to a channel or a group of channels. You can also set up a list of individual users as part of a channel that you would send to. And you also have, I think you demoed, you can go to specific devices, meaning send to all iOS devices, send to all Android devices. Is there a way to say, if I've created a group of users, send to that group, or do I have to create a channel?
I believe it needs to go through a channel. Yeah. Otherwise, well, that's a good. I never tried sending to a group. I've gone to channel and individual device, but I've not tried to a group. So okay. I'll need to try that myself and update the blog notes on if that's possible to send to a group.
Okay.
So with EMS, right, we can create new groups and put individual users into those groups. So the question is, can I now send push notifications to a group that has a specific number of users in it?
Yeah. Because otherwise you have to create channels. So I put the link to push notification to a channel from the doc wiki into the question area. And then there was a question of where does EMS come with, and there was a couple answers. I answered it saying for sure EMS is included as is DataSnap in the enterprise editions of RAD Studio, Delphi, and C++ Builder. But I guess there's some additional ways you can do things. I think Matthias was saying if you have the FireDAC add-on, if you have a professional product and you purchase the FireDAC add-on, that also gives you EMS?
Yeah, I think that's the note in the feature matrix. So it does show EMS in professional, but with a note saying you also need the optional FireDAC pack.
Okay.
To give you EMS.
Yeah, because we need EMS itself is using databases under the covers, right? It's using Interbase under the cover to do the user management and analytics and all of those things. So, so two ways: if you've got professional, FireDAC add-on, or right now, again, the special offer between now and the end of the month, 35% discount to upgrade from professional to enterprise. So there was a question here about session management and DataSnap. So I put in there the link to the lifecycle property, which is part of the server class for doing, for setting up on the server side on a DataSnap server, session management. So session means as the client is connected, they can talk back and forth from client to DataSnap server. You can set up invocation, which just says when the client connects, the client asks for something, a resource, data, whatever it might be, and then it is disconnected. So that's invocation. The last one is server side, where it's up to you as the DataSnap server developer to keep track of all the clients. Stateless, do your own session management on your own. In EMS now, Al, why don't you remind everybody how EMS works, since it's REST-based. When a client connects, it does something, right? And then the connection goes away, and they...
That's correct. So EMS, a REST web service, completely stateless. So scalability is very good with this stateless REST web service. So different than how DataSnap handles its connections.
Yes, someone was asking about, could they run EMS as a service application? And I only know of two ways: running it as a standalone application or housing it inside of Microsoft IIS.
Correct.
Yeah.
So for this development server that we saw, it was running as a standalone executable, either a Windows 32-bit or Windows 64-bit standalone application. Or for production, we will give you an Zappy DLL that you can drop into a Microsoft IIS container and run it that way. So in that case, you can either deploy it on-premise in your own company, or, for example, you may want to pick like an Amazon cloud instance to have it deployed out to.
And then as far as, and you talked about when you deploy, then you contact our sales office or reselling partners to get the deployment number of user licenses you need, and that's managed on the EMS server side. Is that right? How many licenses are
That's correct.
connect?
So that web link on Enterprise Mobility Services on the bottom, it has the different pricing options for bronze, silver, gold, and platinum pricing. But we're also planning some additional EMS pricing options for enterprise solution pricing for internal applications, and also for enterprise solution pricing if you're an ISV OEM to do external deployment. That will come with both deployment and development pricing options. So as David mentioned, it's best to contact us directly or your account manager to get the different types of pricing options that are available through EMS.
So here's a good question. You have for deployment, for development, you have 5 user licenses to do your development, your debugging, testing, so on. And then for deployment, contact our sales officer resellers, and you buy deployment licenses for users. I was asking here, let's say they've used the console, the deployment console application. They've added 5 users. Let's say about a five user packs or whatever. And then they go and delete a user. Does that mean, now they're only using 4 of the 5? So it's not based on the specific user, right? It's a maximum number of users that you put.
Yeah, that's my understanding of how it works.
Yep, it's not. So if you drop, the count is bumped up and down. Okay. Let's see, what is needed to make DataSnap client able to authenticate towards LDAP? I would check out, let's see, it's Pavel's did a DataSnap lab. I think it was his 11th one, but I'll check that real quick. Is there a limitation on push notification use? That's defined by Apple and Google, right?
Correct. Yeah, to my knowledge, right, you're just limited to what Apple and or Google allows you to do.
I don't know of any limit, but you should really check out Apple and APNS and GCM. I'll try to find that link as well and put it in the blog. Let's see. So there's a question here about DataSnap filters and how you can filter in the client. He's using the DataSnap REST. I'll have to do some research, Mike, on because the compression filter. Okay, I'll have to do some research real quick. Can you still use OpenSSL if you choose to? Jim or Al, do you know? I mean, under the covers now, our DataSnap server, EMS server, and our cloud APIs are all using the native HTTP. Before then, in earlier releases, going back to XE7 and B4, we were using OpenSSL. We were using the indie components under the covers. So it required OpenSSL for the different platforms. But I don't know. I mean, I suppose in your own code you could still use OpenSSL, but now I don't.
Yeah. So the
off, right?
Yeah, the native sockets don't have hooks for OpenSSL. They have other hooks to deal with certificates and such, but not for OpenSSL. But you can still use the indie components. You can still use OpenSSL with the indie components, and you can still use OpenSSL with your own code. It's just not something that is built into the native sockets, which is what's used behind the scenes for the EMS and such.
Yep.
Yeah. And I believe I recall for the EMS server, it still requires OpenSSL libraries to support HTTPS requests and for sending push notifications to iOS devices. So I think for that specific case, the OpenSSL libraries are still needed.
Yeah, for if you do backend push, right?
Correct.
Okay. Let's see. Okay, one of these, couple of these. Do you have a good tutorial on JSON-based enterprise business applications? I've put into the blog. There are tutorials on the blog post. So the blog post has tutorial links. I'm also going to add a couple of years ago, I think it was 2014, Marco did a very simple sort of starting tutorial on EMS as well back then. So, but there are tutorial links that you can step through for building both the EMS server and EMS client. And also I put in tutorials in the blog post for building DataSnap servers and clients. Let's see. Is EMS support Apache servers? Right now it's, for EMS it's IIS, right? I know you can take other server applications. Marco did a skill sprint on how to use servers with Apache. I'm not sure if, Jim, do you remember if he did an EMS server running on Apache on Windows?
I don't think that's an option because I believe the EMS modules are pre-built, so I don't think they're. Well, can you do a? Yeah, I'm not sure. I'm pretty sure it's just for IIS, but I'm not positive.
Yeah, I mean,
I have to check on that.
Linux is on our roadmap, so once we have Linux support, which is on the roadmap that we put out a month ago or so, at that point, then we'll have cloud, REST, DataSnap, EMS running on Linux and supporting Apache. So I'll make an assumption that at that point in time, we would also have an option for using Apache on Windows. So it's right now we're still on Windows. When we have Linux server, we will have Apache. Okay, great. Okay, and that answers that. Okay. Oh, here's a question. You know, it's a general question. Does EMS perform better than DataSnap? And you know, I always caution saying, well, it depends on what your applications are doing. But Al, I think you touched on it already in that because with the EMS architecture, the clients come in and go. It's very scalable. You can also just use invocation on DataSnap to connect, get something, and go away. But any advice or feedback about performance, EMS performance and scalability versus DataSnap?
EMS is moving. EMS is more. It's truly a fully, you know, REST stateless server. So for speed and scalability, but DataSnap can also be created as a stateless REST server also. But like I said, EMS is the goal for EMS was to make all of the. So for EMS, you'll create your REST APIs and they'll get published from the EMS server to make it easy and seamlessly consumable by common web frameworks like you mentioned here, like AngularJS. So if you want a complete RESTful stateless service, EMS is probably the way to go.
We know that talking with Marco, he said that one of the design ideas behind EMS was to have a bit more scalability and better performance than DataSnap. So there probably are some things you can do that maybe perform better under DataSnap, but I think generally speaking, EMS is going to have better performance than DataSnap. If nothing else, because of the fact that it is lighter weight and RESTful.
Yep. Yep. So again, the general comment about once we get to Linux server support, will EMS come over DataSnap? All the server side things, building REST servers, building DataSnap servers, building EMS servers, all of that will be brought over. And that's the reason why we keep reminding everybody we're doing Linux server on the roadmap to take all our server-based technologies and also things that developers want to build on the server side, all of those runtime library capabilities, components, and so on. We're not going to do Linux desktop or GUI. We're doing server-side. So that includes middle-tier technologies we have, server-side technologies, FireDAC, all of those things.
And
go ahead.
I'll add that if you're interested in Linux Server, which a lot of people seem to be, make sure you're on update to subscription, because then not only will you get a free update to that, but there's going to be a preview available to update subscription customers to be able to see that. So if you want to get Linux right away and be in the know on that, make sure you're on update subscription.
And as far as pricing, contact our sales office and our reselling partners, the EMS deployment pricing. They'll work with you. We're taking a look at different mixes, as Al kind of mentioned, for deployment pricing, user packs, user counts, and all of that. So the best way really is to contact and talk about the types of applications you want to build and how you want to deploy them. We have different developers who have come to us and said, you know, I'm in a large enterprise organization. We need to be able to deploy this out and let all of our users inside of the enterprise talk to EMS. And then we have other developers who are VARs, ISVs, for example. They want to take EMS and provide a service to some of their customers in their local city, and they might have several different customers, and that the counts wouldn't be as large as a large enterprise. They might be a 3 user in this small business, 5 user in that small business, and so on, 1 user in a sole proprietor business. So that's why we always point you to our sales team to tell them what your deployment plans are. Is it large deployment inside of an enterprise? Is it a multiple small businesses in your area, for example, that might have very few clients? EMS was not architected, for example, for you to run Facebook, you know, as a cloud service, for example, with a lot of endpoints. Although we have plans in the future for how you can scale even larger and deal with multi-tenant tenants sharing the same EMS server infrastructure, but still having separate configuration files, separate user storage, and so on. So again, contact our salespeople. The tutorials, I've got all the tutorial links are on the blog post. So let's see, what is needed to have a DataSnap client authenticate towards, oh yeah, I was going to find Pavel Galatzis, but if you just search for Delphi DataSnap Labs, which is linked, I have a link on the blog post to Pavel's tutorials, and he gives you the source code, and he's got some videos in his DataSnap series. And the one he added, I think, was number 11, callback. So here, I'll just give you a link to his labs, and here you go. Okay. I don't know that he specifically goes to LDAP, but he shows you how you can do authentication, and then from there you would call in. In the case, Al, in the case of EMS, that was added specifically, right? The authentication.
Correct. So yeah. So you could add a custom hook into EMS to not use our built-in authentication, to go outside of EMS's authentication and use external authentications like LDAP or Active Directory.
Right, but we don't have a component that we drop down that's an LDAP component, right? You do that in code?
Correct.
Yeah. Okay.
Correct.
And we give you the hook for doing that. That was in your demo.
Correct.
Okay. All right, so Mike, I'm going to have to follow up with you. I'll follow up with everybody on compression filters and DataSnap using a REST web dispatcher version of DataSnap, and I'll put that on the blog post. Al, there was the question about why EMS when some people may only care about doing REST and JSON applications.
Let me start out by saying our EMS server, it's a REST web service that exposes a collection of predefined REST endpoints. And so our EMS uses REST, and most REST web server extensions return data, and most often in a standard format such as JSON or XML. So our EMS uses REST and JSON. So it's a pure stateless REST web server. And as long as you're working with REST and JSON, it should be easy to use our EMS server. But as David mentions, if you're simply looking to create a REST JSON server from scratch, then that's also possible using components in RAD Studio. If you just want to use like Web Broker and create your own REST JSON server from scratch using Web Broker, that's possible. But our EMS server, it's a turnkey solution to give you all of these management APIs up front to get access to the users and groups inside the EMS server. And we also include that Interbase database, and that's where those users and groups and installations get stored. And we include the Interbase license with the EMS server. And then we give you all these great client components to access the backend data through so if it's in a database, you have our FireDAC connector to get to the backend data, and some nice EMS client components to talk to the EMS server to get to the backend data and return the data back to the calling clients. Hopefully that explains your question.
Yep, and there was another question, Al, and it was actually a couple questions about how to access the users or a specific user, and I think you talked about different URIs that you can pass right to the EMS server.
That's correct. So out of the box, we have management APIs that give you access to users, groups, and installations. And then we also give you APIs to access either all of the users, all of the groups, all of the installations, or individual users or groups or accounts. So for example, there's like on the client, you can use a component called backend users and call its methods, find user, and pass in an individual user just to return one user, or you could return all the users back. And this data gets returned back to the client, and then you can parse that data looking for specific accounts or specific users.
And again, all those are REST call. Everything is a REST call. Everything returns JSON, right?
That's right. Everything comes back as a JSON object. So, and we give you these nice components. For example, either the backend end component or an EMS FireDAC client component to allow you to get the data, and then it gets stored in a FireDAC memory table, and then you can load that data from stream into a JSON object format. And then so no matter which component you're using, so the data from the corresponding component is going to get written to a stream, and then after that, that stream is set in the response to the client. Then you can easily parse that information once received on the client.
Yeah, you can use the JSON, the REST JSON dataset adapter component to take the data and put it into an FDMEM table or a dataset, and then put it in a grid or whatever you want to do as well. So there's lots of support in component-based development, as well as you can look at Pavel's webinar replay and his code where he, for example, there's the whole JSON unit where you can do JSON conversions, date to JSON, JSON to date, there's a whole bunch of different operations that are available if you want to work on the JSON itself versus using bindings, for example, or the components to treat the JSON as a data set, or a subset of the JSON as a data set. So there's all the different options, including just writing your own code to work with the JSON directly. But for me, components and treating this kind of data as a data set that I can play with is a great way to simplify the hard work you need to do when you're putting a user interface, for example, on a multi-device client or a web client or a desktop client.
Correct. In the examples I shown, I simply pointed a FireDAC memory table to a T grid, and it populated the grid with the data it received back from the calling API.
Yep, and
so it's quite easy and simple to do.
Yeah, and I put links to the FD schema adapter that's in the doc wiki. I forget if I put the FD. There's also a JSON connection. I'll make sure that I put that as well. But yeah, FireDAC has this schema adapter, and there's a sample link under the doc wiki that it makes it so easy to use that you just get the JSON, for example, especially at a master detail. You get all the metadata, and the data comes over as JSON. You have the schema adapter, and from there it connects it to FD mem tables, and then you have your customers and orders and so on. It so simplifies what's going on. You know, it all comes over as a big JSON, but then the component pulls it apart again and lets you send it back off to memory tables. And then from there, you've got the user interface. So master detail is simple in a traditional business customer orders application as well. I should mention DataSnap has 2 different project wizards to start from, and that was shown. One is to say, I want to build a DataSnap server using TCP, HTTP, or HTTPS. And the other one is if I want to use a REST DataSnap server. So there's a separate file, new, project, other, DataSnap. Choose the REST web broker wizard, and that gives you a DataSnap server that behaves as a REST server and works with JSON and so on. So DataSnap gives you those choices. And again, EMS, it's REST, it's JSON, and a whole bunch of additional built-in turnkey functionality that you'd have to write yourself if you need it. Analytics, user management, device management, and so on, push notifications. Here's let's see. Oh, can the DataSnap server be installed on a hosted web server? Do you need complete hands-on admin and control and so on, like, say, Azure or whatever, to set it all up? You need to be able to copy the files to the target server. I've got an Amazon Windows instance that I use for demonstrations sometimes, and I have a DataSnap server up there. And what I do is I just RDP, remote desktop, to my Amazon instance, and I copy the files over. And I put them in a subdirectory, and I give people my Elastic IP address and the rest of the URL to get to the DataSnap server, and to make, in that case, web REST recalls. And it goes and gets data, and it grabs images, and then returns them back to a client. So you need some access to be able to copy the DataSnap server and any additional files that you need. Maybe it's database driver files or INI files or some local files of some kind that the application also needs. You've got to put those over there, but after that, you could also, for example, in your DataSnap server, have an endpoint that would be sort of a console monitoring type thing, and you could build your own little client. You could even do file transfer if you wanted to use the ND components or some other mechanism to update your instance. But you're going to need access somehow to copy files, or you need to give them to somebody who has the access to copy the files onto a shared hosted web server or a Azure instance and so on. And there's also installation instructions for EMS in a production environment. That's a link in the doc wiki section of the blog post. So which of these architectures would best fit a series of non-enterprise commercial mobile apps? Well, it depends on what your mobile app is going to do. If your mobile app just needs to, for example, receive push notifications, you could then, we have skill sprints and code rage sessions about how you could build a server-side architecture that would talk to Apple push notification or Google Cloud Messaging if you want to send like stock quotes you're reading on the server side, for example, and sending them to your mobile app. It really depends on what the mobile app wants to do. But for me, when I look at those two, and that's why I put those side by side, EMS and DataSnap, if you want a whole bunch of functionality built in, a turnkey solution for whether it's enterprise or not, you don't need to talk to a remote SQL database. You don't need to talk to a cloud-based service. You could have an EMS endpoint that calculates the sum of two numbers and returns the result, right? Or reads an EMS server that reads a temperature gauge and sends the temperature back of your environment, let's say in your server room, to a mobile application. So if all you do is want to get some data, you could have a REST server, you could have a SOAP server. I mean, there's all sorts of things you can do. It really depends on what that commercial application wants to do. And the nice thing is you have all those choices. The licensing fees for EMS in a production environment, the best thing is, we always say, is to contact sales and our reselling partners. And on the Doc Wiki, in the production and EMS licensing, it directs you to contact us, which gets you to contact our sales officer, one of our reselling partners around the world, because they can talk to you about what your needs actually are, how many users, how many instances you want to deploy, things of that kind. And they can custom put together a quote for what you need and kind of growth. You know, you buy number of, or EMS, you buy number of user licenses, and again, that's users that get stored. As you saw, Al, I think you had two users. One was a test user and then yourself or another user. But you can delete a user, for example, and you can reuse users. That user is just a login and password. So you have you know, if you buy 5 light user licenses, if you only have 5 users, and users could be a process running on a machine, right, that wants to connect to the EMS server. It's really that number of connections of people who log in and do things with the endpoints. So it depends on what you need in your application. But like I say, talk it over with our salespeople. They can figure out what you're trying to do, and working with the field software consultants to put a package together for deployment, the pricing that you'll need. Okay. Let's see. There's a question here. He's using Telerik Kendo UI a lot. It uses JSON as well. He had to reverse engineer the schema for it. We don't have any, well, I should say that. If it's REST, we have our REST debugger. The REST debugger lets you spelunk through REST services, REST-based services, and look at the JSON and so on. It even lets you map the JSON to a grid view. So check out the REST debugger, the Embarcadero REST debugger. On our website, there's a free download, free tool, the REST debugger. So you might use that to sort of spelunk through JSON, REST JSON interfaces. Ultimately, though, if the service doesn't give you some API documentation, I don't know how you would know what the path, you know, the URI endpoint paths are for a REST server, because there's no standard query for what that should be. People do their own thing. They put /this, / that. You could always try to guess, but they won't always be get, put, post, you know, delete, and so on. They can be any kind of API in REST. REST just says HTTP, that you can pass a URI and it'll return some kind of data. It doesn't define a specific path, at least as I remember. So reverse engineering the schema, it's a little easier sometimes if you can get the metadata for a database that, you know, or have administrator access where you can run a tool like ER Studio to reverse engineer the database metadata if you have access to the metadata. But in REST, there really isn't a metadata query that I remember. Jim or Al, do you remember any special thing that's about REST for metadata query? Maybe there's some.
No, there isn't in REST itself. OData, which is a superset of REST, or is built on top of REST, has this concept of being able to query it and find out what endpoints are available and the metadata about those endpoints, what kind of fields they have and stuff like that. But it's not. That's Microsoft's. They call it Windows Communication Foundation data, I think it is. So you can query that and discover that pretty easily, but there's not in REST itself. REST itself is very much, it's more like it's basically, it's like saying it's an in-tier application. It's what when you're saying it's REST. It's describing the form, but not necessarily any of the functionality, any of the way anything necessarily behaves.
Yeah. There's a question here about the FD schema adapter. Is it for REST only DataSnap servers? You can use the FD schema adapter in a traditional client-server application. I don't think the or multi-tier, or even your own personal REST server. I don't think the schema adapter is restricted specifically to EMS or DataSnap. Do you have any advice there, Al or Jim? I mean, as long as you have schema adapter on both sides of a client and a server, or a middle tier and a client, then it will collect up the metadata and data and pass it to the other side, and then pull it apart again.
That's my understanding as well.
I mean, it's just the FD schema adapter is just another of the FireDAC components, but it's not tied to a specific architecture or service. Okay. Is this the Q&A part? Yes, it is. Okay. If you want to install DataSnap servers on a SASB plugin, you need to have access to IIS Management Console. Yes. You've got to do some configuration on IIS to be able to set up paths to DLLs, or at least copy things and set up if you want secure support and so on. That's both for EMS, DataSnap, and anything else that you want to put as an ISAPI DLL.
Now, it's possible your hosting provider might give you some sort of other interface to the IIS management console. So it may be some sort of web version of it or something like that, or something. So it really, you need to, if the hosting provider lets you install ISAPI modules, whatever mechanism they give you to do that, that's what you would use to install DataSnap or EMS ISAPI modules.
Yep. There was a question here, what would be best technology for high data volume application to a rich client? DataSnap REST and DataSnap or REST and JSON. If the two choices were EMS and DataSnap, I would choose DataSnap and use heavyweight callbacks that allows you to open a channel between the client and the middle tier and just blast data back and forth really fast. And then it's just network speed. If you have to convert everything into JSON and then pull it all apart again, that will take a little time if it's really high volume data. Is there another thing, Jim, did you talk about something where maybe there's a way to embed a big binary blob inside of a JSON stream or on a REST call?
You can embed a binary in JSON, and you do that through base64 encoding it. So you base64 encode it and then embed it. So if you're talking about a lot of binary data, you're probably going to want to use DataSnap. If you're talking about a lot of text-based data and it's spread out over a lot of transactions, then that might be where you might start getting better into EMS. EMS is really fast for because there's no state, it's fully REST-based, etc. So that can give REST or EMS some speed advantages and scalability advantages. For example, if you want to, if you need to scale it, you can have multiple REST or EMS servers running, providing different endpoints and load balancing, all that stuff. But so there's some advantages there. So it really depends on the nuances of what it is you're trying to accomplish.
Yep. Okay, there was one here, will EMS be supported on Linux? And the answer is yes. All the server-side things that we have in the product today, our goal, once the Linux server support, that's why in the roadmap, we talk about Linux server, not Linux desktop or GUI. Linux server will be, our goal is to bring over the REST servers, HTTP servers, which is the web broker technology, DataSnap servers, EMS servers, and all the runtime library that's needed to support it. So all the JSON units, all that stuff, right? Memory management, everything. It's server-side Linux on the roadmap, and all of these server technologies will be brought over so that you'll have your choice of Windows or Linux for server-side, and IIS Apache, Apache on Linux side, and so on. Not sure, Al, if this is you or not, there was any support for client-side locks, like a record version that can be tested on a post with current version on the server. Well, one of the things that we do both in DataSnap and in EMS when it involves FireDAC and data caching and applying updates and so on, is that when the data comes over to the client, it's kept there, and as you're making changes, to the data, we're keeping track of those changes. If you have cached updates turned on, for example, then it's kept in a data structure, the original value and the changed value, and then you call apply updates, and it sends the data back as this kind of package. And then on the middle tier side, when the apply updates push that data as updates to the database, you could get reconciliation errors. And that the reconciliation error can either be handled in the middle tier, or it can be passed back to the client side. And there's several on reconciliation error event handlers you can hook, for example, in the FDMEM table and schema adapters and so on, where you get what was the update kind that happened, what was the exception that happened, what was the row that it happened on, the values and such, so that you can do something, pop up a message to the user, hey, something's out of sync, maybe you were offline and you were making changes and saving the changes on the client, and the customer called up the home office because they couldn't get a hold of you, the salesperson in the field, and they made some changes, and then when you did the apply updates from what you knew to be the original state from the database side. So there's this whole apply updates and on reconciliation error mechanism that's built into what we affectionately call the briefcase model, where you're connected, disconnected. It really comes in, especially when you're in the mobile space, where sometimes you're connected to the network and the infrastructure of your company. Sometimes you're not connected, but you still want to be able to process data locally. As far as other kinds of locks that you want, if you want to lock a database, you could do that in code. There's nothing that's automatically built in on the client and server side that I remember, other than a traditional transaction being opening a transaction to a backend database, for example, server. You could provide endpoints for client-side callbacks that would do something like lock a table, lock an image, lock a local data structure, or whatever. But anything else to add, Jim or Al, as it relates to client-side locking mechanisms?
That's actually exactly what I was going to say, is what you said, so I don't have anything to add.